Hello, everyone. Welcome to Can.Do.So. Today, I'm going to show you how to run simple linear regression with R. So first, we are going to show you the correlation and then the simple linear regression and model and interpretation and output of regression. Let's first uh, load the package we are going to use in this lesson. First is tidyverse, and the second one is patchwork, which will put the multiple plots in the same frame. Gapminder is data we are going to use, and GT summary and the cable extra will help us to create a table which looks nice in the report. So correlation. Correlation is a measure of the strength of the relationship between two numeric variables. So what does it mean? Which means we can say the two numeric variable, if they has some kind of relationship, they goes in the same direction or the negative direction, and the relationship is strong or weak. And normally correlation is a number between -1 and 1. And the closer the correlation is to 1 or -1, the stronger the relationship. And the closer the correlation is to 0, of course, which means the weaker the relationship. And it's close to 0, which say there's no correlation between the two variables. And the formula of correlation is like this. It's looks a little complicated, but actually it's just we can say that the denominator is part of covariance. If we plus then this is covariance, and also the denominator is the two variance. It's x variance and y variance and the squared. So it's two standard deviation. So we can see that the correlation is related to variance and covariance, and we have already learned that variance is like this, as I have showed you, and the covariance is like this. And x, the one variables minus the first one's mean, and times the second variables minus the second mean, and get the product and add it together and divided by the degree of freedom. So the correlation is the covariance divided by the product of the standard deviation of the two variables. Or we can also equals to covariance times standard deviation of x and the standard deviation of y. Yeah. So the correlation is a standardized measure of the covariance. So now we can find correlation with R. But before we use the correlation function, let's first take a look at the scatter plot of the two variables. Let's use MT cars, MPG, and WT as an example. And yes, we can see that this actually is the blue line is a linear models regression line. So it's like this. And we can see that this MPG and the weight and miles per gallon is a negative relationship. And we can see that because the dot is quite close to the 9, so we can say that the relationship is strong. It's negatively strong. So, and now we can use the COR function, correlation function, to find out the relationship. So this is actually the correlation matrix. And this line is a correlation to themselves. This is, which means MPG to MPG, and this one is WT to WT. So if the correlation to itself, of course, it's 1. And this one is a correlation of themselves, of each other. We can see that the two value is identical, which means one correlation to the other is equal to the other values correlation to the which means x correlation to y is equal to y's correlation to x. So if we change the order, put weight in front of the MPG, so we will get the same value. So now let's take a look at more variables. One is display against the weight, which is positive and quite strong. And this one is also positive, but I guess this is not as strong as this one, because this one is quite close. All of the values are close to the 9, regression 9. And this one is a little further, and here is a little further, this is a little further. So I guess this will not as strong as this as the previous one. And this one is negative. And we can see this is quite far away. So we can see it's quite weak. And even we will suspect their correlation, but we can test it later. So we use this function to do a correlation matrix. So as we can see in this line, is correlations to themselves, so it's 1. And this one is this one, because this one is WT against this one is WT against MPG, and this one is MPG against WT. So this is identical, yeah. And this one is display to MPG. So you get that here. And we can use this function to get a more understandable concept about the correlation. You can see that as the color is more colorful, and then it's more correlation, and it's the color is white, and it's less correlated. Now let's use patchwork package to put the plots in one figure. We just use plus, and it, it can give us a, yeah, we can see that this one and uh, this one and this one are quite strong, and this one and this one is not strong. And since the correlation between WT and Q-seq is minus 0.17, so we can see that yes, weight is with this one, this minus 17, or also this one. So we can see that it's close to zero. So we can test if it's correlated. We use core.test and the two. So the null hypothesis is that they are not correlated. And since py is quite big, so we do not reject the null hypothesis, which means the true correlation is equal to zero. Now we can use a simple linear regression. We use gapminder dataset to illustrate the simple linear regression. And the research questions is, we want to know, is there a relationship between life expectancy and the GDP per capita? Think about that. I'd say yes, I think so, because as the GDP per capita increase, the well-being will be better, so people can have a better life and can have more healthy care, so that will improve the life expectancy. So, and so we can have a hypothesis that there is a positive relationship between life expectancy and GDP per capita. And the higher the GDP per capita, and the higher the life expectancy. So which means we believe that the higher GDP per capita will improve the life expectancy. So let's test it. Okay, now we can use this one, log LM, which means linear model, and life expectancy is a Y dependent variable, and GDP per capita is an independent variable, and we use data as this. So we use a summary to display the model outcome. And here we can see that GDP per capita's coefficient is 7.649 to the power of 10 times and times 10 to the power of 4. So it looks a little small, but don't forget the GDP per capita is a unit of $1. So which means every $1 increase and the life expectancy will increase by this amount. Don't forget, by GDP per capita, we normally will not consider $1 increase. We normally will consider $1,000 increase. So if it's $1,000 increase, which means we times this by 1,000, it becomes 0.76 year. That's more than half a year, more than three-quarter year. So that's quite big, I think. And we can see this one is there are 3 star, which means quite significant. because we can see that 1 star is already 5% significant level. So 3 star, it's quite close to 0. So we can see that the significant, the effect is quite significant. And we can conclude that the coefficient is significant. And the R square is R square, where is R square? Adjust R square is multiple R square is 34. Sorry, excuse me, there is a typo. It's not 61. It's not 61, it's 34. So in this case, the GDP per capita can explain 34% of the increase of the life expectancy. So I think it's good. I think it's good. So now we use TBL regression from GT summary to present the regression results in a table. And if you want to try, you can copy this command code. It's this big beautiful table. Yeah, because this is a slides type outcome, so it's look a little different. If we render it to a PDF, and we can use Stargazer or other functions to create table, but this one is I think is good. Okay, that's all for today's lesson. In this lesson, we learned how to find the correlation between two variables and how to use simple linear regression to find how one variable might affect another variable and to what extent. And in the following lesson, we will learn how to use multiple linear regression to find how multiple variables might affect the dependent variable and to what extent. Okay, thank you for watching. And as always, if you have any questions or suggestions, just leave a message below. I will respond to you as soon as possible. And if you like this video, please share it and like it and subscribe my channel. You will help me to improve this channel. And see you.